Hello and welcome. This is Cambridge O-Level Physics paper number 1, multiple choice. This is October-November 2021 offering. The subject code is 5054 and this is the variant 2 of this exam. Let's start. First question. It says a boy starts at P and walks 3 meters due north from P to Q and then 4 meters due east from Q to R. What is the shortest distance that he must now walk to have the overall displacement of 0? So when solving this question, we have to keep in mind that in order to have a displacement equal to 0, a person must reach the point from where he started his or her journey. So if he started his journey at P, he must return at P. So, and the shortest distance in all this path is from R to P, and this distance is 5. So the answer is C. Next question. A student investigates the motion of the ball falling through the air. Which is a vector quantity? Number A, diameter of the ball. No, diameter is not a vector quantity. The gravitational force on the ball. Yes, the gravitational force G is a vector quantity. Okay. Number C, the distance from which the ball is dropped. So distance, no, distance is a scalar quantity. The speed at which the ball hits the ground, no, the speed is again a scalar quantity. The velocity is a vector quantity. Similarly, again, in respect to the distance, the displacement is a vector quantity. So the answer is B. Number 3, next question. A skier slides down a slope. The diagram shows his speed varies with time. What is his average acceleration during the 6 seconds? So here is our graph. So from our graph, what we see from here is that the velocity settles something at 26 meters per second. So acceleration is velocity per unit time, or from this graph, change in velocity per change in time, or overall slope. So the average for all this journey, we can say that 26 minus 0 divided by t6 minus 0. That will give us sort of an average for this whole journey. And this acceleration comes out to be 4.3333 meters per second square. And the best answer is B. Next question. It says a solid object immersed in water hangs from an elastic thread. So this is a solid object. This is the thread. Three forces act on the object. Number 1, its weight. So the weight of the object will act downward. The tension in the tension in the thread T. So the tension will act in this manner. And the force from the water. And the force from the water will act on the object in this direction, F. The force F acts upwards. F acts upwards, given on the here as well. Which equation is correct when the object is stationary? So just add the forces as compared to the in accordance with the vectors associated with them. So T plus F is equal to W. So we can write that W minus F minus T equals to 0. So something on these grounds will be the uh, right answer for us, or so W minus F minus T. So minus F minus T equals W. So, or we can also write it as W, or sorry, T plus F minus W equals to 0. So anything amongst them which relates to this. So this equation F minus W plus D is something that is here. So the best answer is D from this equation. So this thing relates to this. This is the best answer. Next question. Question number 5. It says the diagram shows a car going around a circular track at a constant speed. Which arrow shows the direction of the resultant force on the car? So the car is moving in a circular path. So in a circular path, the centrifugal force will be acting on the car, and that centrifugal force will be directed towards the center of the circle or the circular path. So this force that is shown by D is going towards the center of the circular path. So answer D would be the right answer. Next question. A temporary, oh sorry, an object in a lab in a lab an object in a laboratory is used to determine the gravitational field strength G, which quantity is equal to G. So remember, weight equals to mass times gravity. So gravitational or the strength or G is equal to weight divided by mass. So mass of the object, no, weight of the object, no, weight divided by mass. So weight, this is our weight and this is our mass. So yes, this appears to be right. Mass over weight. No, this is inverse. So answer C is the right choice. Next question. Question number 7. It says a student takes measurements to find the density of a regular shaped block of a regularly shaped block. Which formula is used to calculate the density of the block? So for density of a block, so density we know that is equal to mass per unit volume. So that is the formula. So R A density equals to mass per unit volume. A is the right choice, and that formula matches our formula. Next question. It says 4 solid objects are made from same material and have equal volumes. Which object is most stable? So in order to find such objects, we have to, first see or try to find out the center of gravity of all these objects. So if this is a circular object or if it's something related, some some point here will be the center of gravity for this box or this cylinder. Somewhere here will be the center of gravity for this. If you make a line this, some line like this, somewhere here will be the center of gravity for this. A line from here, a line from here, a line from here. So the lowest lying center of gravity will be the one with most stable. The second thing we must look for is the object with a wider base. So the more wider the base, more stable will be the object, because wider base allows the object to have a lower center of gravity or lower center of mass. So amongst them, these two are almost equal. This is the highest one. This is a little lower than the previous one. This is low, and this is the lowest one with a wider base. So answer D is the best choice we get. Next question. Question number 9. It says a metal wire is stretched by a force F up to the proportion up to the limit of proportionality. Which statement describes what happens when F is increased slightly? So if we draw the graph between force or we can say force over here, X over here, so it has reached limit of proportionality. So if after the limit of proportionality is reached, if we increase the force, the string will expand or the wire will expand, but it will not follow the proportionality limit. So the wire breaks. No, the wire continues to extend, but not directly proportional to F. Yes, the wire continues to extend directly proportional to F. No, the wire does not extend any further. No. Since metals can expand further as well without breaking, the answer B is the best choice we have in this condition. Next question. It says a piston X is pushed into an hydraulic cylinder. Piston X produces a pressure Px in the liquid in the cylinder. This diagram shows the cylinder viewed from above. So piston X produces a pressure Px. There are other two pistons piston Z and piston Y in the cylinder. The pressure on piston Y is Py and piston over here is Pz. What is the relationship between Px, Py, and Pz? So remember, the pressure whatsoever is exerted by any of these pistons that remains same throughout the cylinder, and it's a property of pressure. And since pressure remains same on all the cylinder, uh, the area of the piston determines whatever the force that is acting on the piston. So usually a mistake which makes that force X is not equal to force Y is not equal to force Z. This is something that is right, because forces acting on these pistons are not equal, whereas pressure acting on all these pistons are equal. So usually what students do is that they confuse the force and pressure and interchange them, and in a way they say that okay, the least one the area will have more pressure. No, the pressure will remain same throughout this piston, and if you are asked to find out the force, yes, the forces will be different, and that can be solved in another fashion. So an answer D is the right answer. Px is equal to Py is equal to Pz. Next question, question number 11. It says air is trapped in a cylinder by a piston. The pressure of the air is P, or sorry, rho, and the length of the air column is 20 centimeter. The piston is moved outwards. The length of the air column increases by 40 centimeter. The temperature of the air remains constant. What is the new pressure? So remember, P1 V1 over T1 equals to P2 V2 over T2. This is the equation we are using. Temperature is constant. So P1, remember P1 is rho, volume is directly proportional to length, so we assume we can say that it is 20 centimeter. P2 we have to find out volume 2, the new length is 20 plus 40 or 60 centimeter. So P2 is rho times 20 divided by 60. So it becomes rho 2 by, so rho 1 by 3, or P2. So rho by 3 is the new pressure. So answer B is the right choice we have. Next question. It says a 60 kg ice skater traveling initially at 3 meters per second glide across a horizontal surface. The skater brakes and comes to rest after 5 meters. The work done against the braking force is the change in kinetic energy of the skater. What is the braking force? So how we are going to solve this? First of all, we are given the mass of the skater, the initial velocity, and uh, the distance it has traveled before coming to rest. So let's see what we can find out from here. So first of all, we can find out the kinetic energy. So kinetic energy is half mv square. So half, mass is 60, velocity is 3 meters per second square. So 9 into 30, this is 270 joules. So this is the overall kinetic energy, and it is said that the work done against braking force is the change in kinetic energy. So change in kinetic energy is this basically, or in actually, if we have to find out change in kinetic energy, that will be delta V, mass V initial minus V final square. So mass is 60, initial velocity is 30, final it is at has gone to rest. So both will give you the same values. This is the more exact way of solving it. This is 240 joules. So remember, work done again is calculated in joules. So we have the joules with us. Force multiplied by the distance traveled in the direction of force. So for example, this is the skater, this is it is skating, so it skates down and comes to rest over here. So the braking force is acting in this direction. The overall distance is 5 meter. Uh, so eventually force into distance, force that is the braking force, distance is 5 meter. Overall energy that is converted is 270 joules. So force becomes equal to 270 divided by 5. It comes out to be 50 4 newtons. So the answer C is the right choice we have. Next question. So which equation is used to find the efficiency of energy transfer? So remember how energy transfers looks like. So there is some energy output, there is some energy input, and efficiency is whatever the useful energy output divided by actual energy input multiplied by 100. So we do not have any 100 over here. That is fine. So efficiency, useful energy output divided by useful energy input. Yes, it looks like energy input divided by useful energy out. No, it is inverse of efficiency. Efficiency, energy converted into the required form, total power. So if there is energy, must be divided by energy. If there is power, it must be divided by power. So the units must remain the same. So this is not the right answer. Efficiency, energy converted into required form multiplied by total. No, this is not. So answer A is the right choice. Next question. It says the diagram shows inside of a refrigerator. When the refrigerator is first switched on, what happens to the air near the cooling unit? So refrigerator is switched on, cooling state starts to take place. So the air near the cooling unit cools. So when the air becomes cooler, the molecules move close to each other. So move close to each other, move close to each other. What happens to the density? So when the molecules move close to each other, the density technically increases. So or increases. So best answer is D. Next question. What is the color and texture of a good absorber of infrared radiation? So good absorber, uh, color is black, texture dull surface, shiny surface, good reflectors, white surface, bad absorbers. So dull and black. Answer B is the right choice we have. Next question. Question number 16. It says which temperatures are used as lower and upper fixed points for a mercury in glass temperature. So for a mercury in glass temperature, upper fixed point, boiling point of water, lower fixed point, freezing point of water. So room temperature, no. Room temperature, no. Boiling point of water, yes. Boiling point of mercury, no. Boiling point of water, yes. Uh, Freezing point of mercury, no. So answer B is the right choice we have. Next question. Two liquid in glass thermometers have identical dimensions. One contains ethanol uh, and the other an equal volume of mercury. Ethanol expands more than mercury for the same temperature rise. How do the sensitivity and range of ethanol thermometer compare to those of mercury thermometer? So sensitivity of ethanol will be larger, and for same distance, mercury will be expanding less. So it will be having lesser sensitivity. On the range side, mercury will give you better range or more range compared to ethanol, because if say a thermometer is 10 centimeters long, the ethanol expands more quickly than mercury for a same degree rise in temperature. So ethanol will rise to 10 centimeter in more for less temperature, whereas mercury will rise for 10 centimeter for larger temperatures. Overall, the range for ethanol thermometer will be smaller, sensitivity will be greater. So answer B is the right choice we have. Next question. It says solar panels are used to heat water with a mass of 500 kg. Total area of solar panels is 10 meters square. The average power output from each square meter of panels is 300 watts. The specific heat capacity of water is 4200 joules, 4200 joules per kg degree centigrade. What is the increase in water temperature after 8 hours? So remember, Q equals to mc delta T or delta theta. So mass is 500 kg. Specific heat capacity is 4200 joules per kg degree centigrade. So this is basically kg. This is Q. And temperature. Uh, what is the uh, increase in temperature was? So delta T we have to find out, right? And what is actually the energy joules that is available to us. So we have to find out Q as well. So solar panels, remember, total area is 10 meters square, and average power output of each meter square. 1 meter square gives an average power of 300 watt, right? Average power of 300 watt. 10 meters square will give a power of 300 or 3000 watts, right? So this is 3000 watts, uh, and this is basically power, and units of energy or joules we have, they are basically in kilowatt hours. That is the energy. So if we have to convert it into kilowatt hours, so 3000 divided by 1000. So this is your kilowatt. Number of hours is 8 hours. So for 8 hours, so you have 8 hours over here. So this becomes 24 kilowatt hours, or that is the unit of energy we have. Now uh, since you can say this is 8 hours, so we have to basically uh, mm, right. So basically this, instead of hours, kilowatt hours is also a unit of energy, but if we are going to convert use the energy over here, they must be in uh, seconds basically. And this is not or this is actually in power. So joules over here is watts multiplied by seconds. That is the area of this is what is done when we solving electricity or these sort of things. So watts to energy, so we do not convert into kilowatts. So 3000 multiplied by 8 hours multiplied by 60 will give you number of minutes, and multiplied by 60 will give you number of seconds. So your total Q is equal to 60 into 8 into 3000, and that is equal to 500 multiply by 4200 multiply by delta t. So if we are going to calculate delta t from here over here, so our delta t will become something like 41.142 degree C. So this is the change in temperature of water. So the nearest correct answer is this, D, 41. Next question. Question number 19. It says the graph is the temperature time graph of a sample of wax that is uh, heated so that it melts. The mass of the wax is 200 grams. The thermal energy supplied to wax at constant rate of 12,000 joules per minute. What is the specific latent heat of fusion? So remember, when during specific latent heat, the temperature doesn't rise, whereas the state of the material changes. So in this graph, we can see from here to here, almost from 3 minutes to 7 minutes, that the temperature is not rising, whereas the energy is being taken up, and the uh, state is changing. So this is the latent heat of fusion. So material basically fuses or changes its state, whereas at constant temperature, or the temperature remains same. So Q equals to M L. That is the formula. So the latent heat is given to us. A mass is 200 grams, and time taken is 4 minutes. So let's see. Thermal energy 1200,000 joules per minute equals to mass is 200 grams, and What is the specific latent heat? So latent heat or small l we have to calculate. And time is, from here we can see that the required time is 4 minutes. So we have to multiply it by 4. So 4 into 1200 divided by 200 is your latent heat of fusion. So this one, two, so this becomes 240 joules per gram. So answer B is the right choice we have. Next question. Question number 20. It says the temperatures of water in 4 beakers are different and areas of surface of water are also different. Which beaker the rate of evaporation of the water is greatest? Temperature. So higher the temperature, more will be the rate of evaporation. So amongst these temperature, these two are the most likely to have greatest rate of evaporations. Okay, so surface area of water, more the surface area, more will be the area available for the molecules at the surface to escape the surface of the water, thus evaporation to take place. Therefore, we can say that this and this will have more evaporation. So eventually, answer D is the best choice we have. Next question. Question, it says the diagram shows one wave front of a wave as it travels from deep water to shallow water in a ripple tank. What happens as the wavefront moves into the shallow water? So remember, V equals to F lambda is the equation. For a ripple tank, remember the frequency remains constant. For ripple tank, F is equal to constant. So uh, in so this is my ripple tank. So this is my shallow region. This is my deep region. So if my wavelength is something like this, my wavelength will be something like this over here. So my lambda 2, this is my lambda 1. So lambda 2 is much less than lambda 1. F2 frequency remains same. So my, it means that V2 is much less than V1, right? So we can see from here that the speed of the wave should decrease or the wavelength of the wave should decrease. So first half, speed of the wavefront increases in shallow water. No. Speed of the wavefront decreases. Yes. The wavelength of that remains constant. No. The wavelength increases. No. The wavelength should decrease. So answer is this. So answer B is the right answer we have, or the best choice we have. Next question. Question 22. Example. Which example describes a transverse wave being refracted? Which is the, so number one, infrared waves traveling in an optical fiber. So optical fiber is total internal reflection. That is on which optical fibers work. So no. Light waves from an object entering a magnifying glass. So magnifying glass light waves as they enter from air to a glass medium, the light waves refract, right, and reflect and refract both. So this is a relatively good choice to have. Ultrasound waves being used to clean jewelry. So no, this is no refraction. There is only reflection that comes play. Water waves hitting a barrier. So water waves hits a barrier and reflects back. So answer B is the best choice we have in this case. Next question. 23, it says light reflects from a plane mirror as shown. Which row is always correct? So uh, the symbol of the angle of x is angle of incidence I, angle of x y is incidence I, angle of x is angle of reflection. uh, so angle of reflection, similarly, x degree is equal to y degrees. Both angles are same, or angle of reflection is equal to angle of incidence, or basic Snell's law, or law of reflection from a plane surface. So answer symbol for x is a reflection, yes, and y equals to x. So answer C is the right choice. Next question. It says a piece of paper torn from an exercise book shows an object is further away from the lens, the focal point, and the image is upside down. So image is upside down. What is being which process is being described here. So upside down image, oh sorry, so an upside down image is generally a uh, you can say real image. So this one thing is talking about real image. So first thing we can say it is about a real image. Yes, real image. So these A and B are not the answers. Okay, now let's see. It's the object is far away from a lens. So object is somewhere far away from the lens, and and this is the focal point lens. So, and it the image is upside down, uh, something like this. So so only we can say that it's a converging lens. Lens can form an image like that. So if we have a diverging lens, for example, like this, and the object is far away from focal length, so image will be uh, again on the same side of the lens and would be vertical. So some eventually we have answer D is the best choice in this case. It's talking about a converging lens and it's talking about a formation of a real image. Next question. It says a girl is long-sighted. So which statement is correct? She, number one, she sees close objects less clearly than a person with a normal vision. First of all, yes, this happens in long-sightedness. That is actually the issue. So it looks like a good. She sees distance object more clearly than a person with a normal vision. So I mean, this statement itself is a contradictory. So normal vision means that you see distance and objects and close objects in a normal fashions. It's not like that you something can only increase your normal vision. Either you're using binoculars or some sort of eye or some sort of lens sort of mechanism. So no, this is not the right choice. Fault is corrected with the diverging lens. So no long-sightedness is con, uh, corrected with converging lens. The image of the close object is formed in front. No, it is formed behind the retina. So the answer best over here is A. So these three are not the right choices we have. Next question. It says, in next question, it says uh, the light rays are deviated by a prism. The deviation angle D is measured for light rays for different frequency, including blue light and red light. Which of the graph of D against frequency is correct? So first of all, when the white light enters, it uh, deviates, it goes into its constituent color. So or we can Vib GYOR, right? And for WebGeor, we have violet is at something around 400 nanometers of wavelength, and red is around somewhere around seven. Sorry, 700 nanometers of wavelength. And for diffraction, we know that smaller wavelengths diffract more, right? More, or you can say deviate more. So smaller wavelengths, so something, so we can see that amongst the blue, it's talking about blue light and red light. So blue is here, red is here. So we see that lambda blue is less than lambda red. So blue light will deviate more, red light will deviate less. So somewhere like this. So it would be red, this will be blue. So we're having a deviation pattern. So red will be on the lesser side, blue will be on the higher side. So blue high, red less. And remember, frequency is if we are increasing, so C equals to F lambda. So if our you can say C and F remains constant, if lambda is increasing here, so your frequency is increasing on the opposite side. So for frequency, we have F red and we have F blue. So frequency of blue light is more than the frequency of red light, and overall product remains same. So frequency of blue light is more, so blue. So this is not the right answer. This is not the right. So frequency blue more, red less. Deviation blue more, red less. Answer D is the right choice. Next question. Question 27, it says that a satellite orbits around Earth at a height of 300 kilometers above the surface. The speed of electromagnetic waves is 3 to 10 to power 8. What is the minimum time taken by a radio transmitted signal from Earth to reach the satellite? So distance 300 into 10 to power 3 meters, speed 3 into 10 to power 8 meters per second, time is distance but divided by speed. Distance is 300 into 10 to power 3 divided by 3 into 10 to power 8. And this thing comes out to be uh, 1 into 10 to power minus 3 seconds. So answer C is the right choice we have. Next question. Which of the following more closely associated with echoes? Focusing, reflection, refraction, total inter no, total interaction, refraction, no, reflection, yes, focusing, no. So answer B is the right choice. So echoes are basically the reflected sound waves which our ears hear, or which are collected by the receiving sensor or anything that is measuring echoes. Next question, question 29. An ultrasound scanner produces an image of an unborn baby. What what does the scanner use to form an image of the baby? Number one, ultrasound absorbed by the baby, no. Ultrasound emitted by the baby, no. Baby emits nothing. Baby absorbs nothing. Ultrasound reflected by the baby, yes. Ultrasound refracted, again, there should not be refraction. They can't measure it. The sensor and the transmitter both are over here. So answer C is the right choice we have. Then question number 30. A small plotting compass is placed near the bar magnet as shown. Which diagram shows the direction of the compass needle points? So magnetic field from north should be pointing from north to south, and the compass needle should be pointing something in this direction. So which diagram shows? So compass magnetic north will be something like this. So which diagram shows the direction of the needle compass? A would be the diagram of the needle compass. Next question, question 31. It says positively charged plastic rod is held near but not touching an insulated and previously uncharged ball. No charge leaves the rod. What are possible charges on the left and right side of the ball? So on the left side, this positive rod introduces negative charges, uh, and equally uh, uh, opposite positive charges are induced or moved towards the right side of the ball in order to compensate that, or because the Gaussian surface, the total charge, net charge remains same. So eventually, uh, on the right side, on the left side, negative charges, and on the right side, equal but positive uh, charges. So 2 10 power 9, 1, so the charges are not equal. 2 into 10 to power minus 9 amperes. To again, charges are not in amperes, so again these are not the right choices we have. Minus 2 into 10 to power 9 coulombs, for example, and positive 2 into 10 to power 9 coulombs. This appears right. On the left side, no. On the left side, there is negative charges, and on the right side there are positive. So answer C is the right choice we have. Next question. Question 32. It says which circuit is connected to measure the current through a fixed resistor and the potential difference across the same resistor. So here we have a source. Remember, voltmeter must be connected across the so this is our fixed resistor, 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 this is variable resistor, again this is variable resistor, this is variable resistor, this is variable resistor. So voltmeter must be connected in parallel, and current must be connected in series with the resistor. So again, since this is a series circuit, the current in the series circuit must remain same. So if we connect ammeter here, ammeter here, I mean, both will give us the same value of current. So the both are fine. Voltmeter must be connected in parallel across R. So in parallel across R, this is the right choice. Voltmeter in series, no, this is not a right choice. Voltmeter in series, again, this is not an ammeter in parallel. This is even, I mean, it's a way, it's a ridiculous choice at the moment. Here, what is here? So here we are basically measuring the voltage that is appearing across both the variable resistance and the fixed resistor, and current across the fixed resistor can be measured with the help. So this is partially correct, partially. So answer A is our right choice we have. Remember, voltmeter must be connected against the component against for which we want to measure the potential difference, and the ammeter must be connected in series. Next question, question 32. Uh, quantity X and quantity Y have same units. Unit Z. X is the energy dissipated by the battery in driving unit charge around the complete circuit. So X energy dissipated by the so X is you can say electromotive force. Yes, energy dissipated. It is basically talking about EMF. Y is the work done in a component in driving unit charge through the component. So this is the voltage or the potential difference. Potential difference. So what are X, Y, and Z? And both, again, this is measured in volts. This is measured in volts. So units for both are volts, and same units, so volts, and X is EMF, Y is potential difference. So answer B is the right choice we have. Next question. Question 34. It says a transformer with an efficiency of 100% has a primary voltage of 600 volts and a secondary voltage of 240 volts. The secondary coil is attached to a resistor of 120 volt. What is the power dissipated in the resistor? P R, you have to calculate. And what is the current in the primary coil? So power dissipated, remember, P equals to V I or V square by R or I square by R. So here we are given the voltage and the resistance. So we just simply PR resistance 240 square divided by 120. So 240 multiplied by 2, 480 watts. This is the power. So answer C and D can be right choice. So let's find out the value of current. So remember, ideal transformer NP over NS, number of turns on primary equals to number of turns on secondary, is equal to voltage primary by voltage secondary, and this is equal to I secondary divided by I primary. So voltage primary divided by voltage secondary. So voltage primary is 600 volts divided by 240 volts. I secondary, we are not away up. So I secondary we can calculate. So from here we can calculate I secondary. So power is 480 watts. And if I divide it by 240 volts, that will give me I secondary, and that is equal to 2 amperes. So, and I secondary is 2 amperes here. So IP is 2 into 240 divided by 600, and IP becomes equals to 0.8 amperes. So answer D, or this one also answer C is the right answer for this question. Next part. Question 35, it says the diagram shows an alarm system in which switch S is closed down. Switch S is closed down. The top circuit is arranged so that the electromagnet is positioned over the soft iron contact. What happens if when the switch S is opened? So if you are going to open the switch S, what happens here is that there is a momentary change in current across this electromagnet. The momentary change in current across this electromagnet will produce a change in magnetic flux, and that change in magnetic flux will result in what? So if there is change in magnetic flux, this is a iron contact. For example, so this is positive here, positive, north pole here, south here. So when switch is opened, this north immediately changes to south, and this comes north, and this south pole induces a north pole here because of the Lenz's law, or basically it attracts the iron over here. And what happens here? So initially there, or you can say that initially there is a north pole here, uh, and introduces another, or magnetizes it. uh, so what happens to iron contact, or you can say it, this iron contact is held at this position because of this energized electromagnet. So this is these de-energized, this iron contact falls and drops to the metal. So it drops to the metal, uh, and what happens, the bell starts ringing. So the bell starts ringing. So the answer A is the right choice we have over here. So the easiest way to explain this is rubber. No, it's not coming, but anyways. So easiest way of explaining this is like this. So next question. It says the diagram shows an LED connected to a circuit with a resistance, with a resistor and an AC power supply of frequency of 2 hertz. Which statement is correct? LED doesn't light, so it is AC supply of 2 hertz. False. LED will light. The LED flashes twice each second and off twice each second. Okay, the LED flashes 4 times in each second. So 2 hertz, what is the frequency of 2 hertz means? So frequency is 1 by time period. So 1 divided by 2 is t, and it is equal to 0.5 seconds. So time period is 0.5 seconds. And so in 0.5 seconds, this and this. So in 0.5 second, 1 cycle passes. And so now what is happening? So when the positive cycle comes, light emitting diode, so positive cycle come, the light, that diode will be forward biased, light emits. When the negative half cycle comes, the diode will be reverse biased, the light will not emit. So in 1 second, 1 positive cycle, 2 positive cycles. So the LED will blink twice in 1 second, and switch off, turn on twice in 1 second, and turn off twice in 1 second. So twice in each second, and flashes twice in each second, and twice so turned off in during each second. So answer B is the right choice we have. Next question, question 37. It says a little statement about production of electricity in a nuclear power station is correct. What statement? In the reactor, the main reaction occurs when proton hits uranium nuclei. It is basically neutron that hits nuclei during fission reaction. So the process, no, this is not the right choice. The process taking place in the reactor is called nuclear fission. No, it is fission, not fusion, it is fission. The reactor produces energy to boil water and produce steam. Yes. Carbon dioxide is major waste. No, this is carbon dioxide is waste for coal based or any fossil fuel based power plant. So this is no, there is no waste, only the waste is steam and some nuclear waste material. So the answer is C, that is the right choice we have. Next question. It says a radioactive sample contains an isotope that emits alpha particles. So remember, alpha particles, which quantity stays constant. So for any alpha particles, in a radioactive decay, the half-life of an isotope remains same. Yes, half-life of the isotope remains same. First part. Mass of the sample, no. So it's a radioactive sample. The, the mass of the sample halves after every half-life. it's been passed. So no, the number of neutrons in the sample. So after alpha emission, remember it is 4 2. So the neutrons will change. The rate of decay of the isotope. So no, the rate of decay of the isotope is more dependent on the half-life. So no, it is not constant, doesn't remain same. So answer A is the right choice we have in this case, or the best choice we have. So next question, it says question 39, in a simple model of an atom x around y, what are x and what are y. So x, it is something that is revolving around the nucleus, so these are electrons. So y is nucleus. So y is nucleus, x is electrons, yes, electrons, protons. So answer A is the right choice we have over here. Next question. And the last question, question number 40, it says, how do the proton number, atomic numbers, and the nucleon numbers, mass numbers of two different isotopes of same elements compare with each other? So isotopes, the definition of an isotope is that it have same number of protons but different number of neutrons, or different number of neutrons, and so basically different nucleon number. So same number of protons, same number of protons, different number of nucleon, different number of nucleons. So answer C is the best choice we have. So this is how, or this is the last question of this exam, and I hope you have understood it. I hope you have liked my effort, and I wish you all the best for your exams and upcoming whatsoever sort of assessments you have. Thank you very much, and thank you very much for listening.